This is the Chapter 8 Form A handout that was given in class. We're looking at questions 21 to 24. They are involving complex numbers. Express your answer in A plus BI form. So one piece will have no i's and the other piece will have i's with an addition in the middle. That's what that means. So I'd like to combine. I'm just adding and subtracting all the terms. First thing we need to do is get rid of the parentheses so we see what we have, just like polynomials. So in a way, think of this I as a variable in itself. It's not a variable. It has value, so you could do a little more with it, just like the square roots. But we've got 5 minus 6 plus 8. And when we combine those, we end up with 7. And we have negative 9i plus 2i is negative 7i. That's it. Complex number minus complex number plus. This is actually a complex number with b equaling 0. This is an A plus BI form. Next thing we want to do is multiply. Looks like a binomial times a binomial. Treat it like a binomial times a binomial. 5 times 3 minus 5 times 2i, think of it as an x, plus 2i times 3 minus 4i squared. Sorry about that, I multiplied 2 times 2. This is what you need to know, that I squared equals negative 1. Let me rewrite this. 15 minus 10i plus 6i, negative 4 times negative 1 is positive 4. Now these combine to be 19, and these two combine to be negative 4i. That's it. Next we have division. But this is really I equals the square root of negative 1. It's really a radical. We cannot have any radicals or imaginary numbers in the denominator. How do we get rid of this? We multiply by its conjugate. What we do to the bottom, we have to do to the top, so that we're really multiplying by 1. So it's going to keep the value of this. In the denominator, 8, we're going to have 8 times 8 is 64. Then we're going to have positive 24i, negative 24i, which is going to cancel out. Then we have negative 3i times 3i is negative 9i squared. Bingo, that's a minus 1. Continuing along the bottom, 64, negative 9 times negative 1 is plus 9. So that bottom just becomes, when you add those together, you get 73. Backing up to the top, this is a binomial times a binomial. I need to distribute. That is 48 plus 18i plus 8i. I times positive 3i is positive 3i squared. That is negative 1. So what we have, I'm going to combine these middle two first. 48 plus 26i minus 3. These two combine. We do have the positive 26i. 48 minus 3 is 45. There is not much you can do with that. But we must put it in A equals BI form. Right now it's not. So let me just share this denominator. That I is I over 1, which is just I. So there's your A, and there's your B, I. A plus B, I form. Again, that's it. As you can tell, I find these kind of fun. Perform the indicated operation, express your answer in A plus BI form. I to the 21st. Well, we know I squared equals negative 1. Okay? I to the fourth then equals I squared times I squared, which is negative 1 times negative 1, which equals 1. So it's kind of like back to 1. So we can break this down into fours. What 21 is equal? 21 is equal to 4 plus 4 plus 4. Why am I adding them? Because I want to make a stream of ones. 4 plus 4 plus 4 is 12, plus another 4 is 16, plus another 4 is 20. I'm almost there. I need one more. So I'm going to rewrite this as I to the 4 times I to the 4 times I to the 4 times I to the 4. That's 4 of them. That if when I add them up, it's a 16. There's I to the 20, and I need an extra I. What I'm doing here is each one of these has what value? 1. 1 times 1 times 1 times 1 times 1 times I. Well, guess what? That is just I. Sometimes it's denoted in a clock. 0, 1, it's the I clock. 2, 3, and then when you get back here, well, first off, I to the 0 power equals, anything to 0 power equals 1. So the value up here is 1. I to the first power is just I. I to the second power, we went over already, is negative 1. So let's just break down I to the third power. I to the third is, well, let's say I to the squared times I to the first. Make sense? This is what? Negative 1. So it's negative 1 times I. That would make I to the third equal to negative I. Negative 1 times I is negative I. So this would be negative I. So with a negative 1, when you keep multiplying a negative 1, you're going like this. With I, it's only negative 1 to the 1/2 power. I equals negative 1, the square root of negative 1, or negative 1 to the 1/2 power. This is the half power. This is the first power. I to the, does that make sense? No. Negative 1 to the half power, negative 1 to the first power, negative 1 to the 3/2 power, negative 1 to the 4/2 power, or squared, negative 1 to the 5/2. 6/2 is just 3. Negative 1 cubed is actually negative 1. Negative 1 to the 7/2. Negative 1 to the 8/2. Negative 1, 9/2. 10/2, 11/2, 12/2, 6. Negative 1 to the 6th is just 1. So these are kind of the half power. These i's are the half powers. When we have even powers of I, we're either going to be 1 or negative 1, depending on whether the power is divisible by 4. Yeah, divisible by 4, and then 1 I left over. So the answer to this question is just I. You don't need I to many powers. They simplify.